Well, hello again, everyone. This is Mr. Reeves back with you, and today we're going to be looking at finding the area of a circle. So you can see our essential question here is how do you find the area of a circle? Right here, I have a circle, and we're going to talk about finding the area. Quick review on the previous lesson, we were finding the circumference. The circumference of a circle is the distance around the outside of the circle. And hopefully you remember the formula for finding the circumference of a circle. The circumference of a circle is the diameter times pi, or another way to find the circumference of the circle was 2 times pi times the radius. Because just a reminder, 2 radii, or 2 times the radius, will give you the diameter. So whenever you see d, you can replace it with 2r, or wherever you see r, you can replace it with d divided by 2. So that was circumference when we were finding the circumference of a circle, again, the distance around the outside. But now we want to find the area. Well, what is the area of a circle? The area of a circle is not going around the outside, it's filling up the inside. So when we want to find the area of the circle, rather than saying how far is it to go around the outside, how much space does it take to fill it in? And when we find area, we measure area in terms of a square. So we're saying how many squares can I put in this circle? Now, I hope you can see we're going to run into some problems because when you get to the edge, what happens? You can't get the whole circle there. And that's where this number pi comes in. Pi, the irrational number pi, is what allows us to find the area in terms of squares, even though we can't really make a curve on a square. So if you're wondering why pi, that's why pi. Maybe in another video sometime we'll do a little more investigation on where pi comes from and why it's so important. All right, so in your book, if you took a look, what they did is they took that circle and they broke it up into parts and they derived the formula. So we're not going to go through deriving of the formula. We're just going to skip straight to the formula. The area of a circle is pi times the radius squared. So again, if I want to know how much space is inside this circle, and I know I'm not getting all the space, there's still some little white spots, that's all right, we're not going to worry too much about it. If I want to know how many squares can fit in there, this is the formula. Area equals pi times radius squared. Now I do want to remind you that there is also on this circle not just the radius, but every circle has a diameter. And many times when you're doing these problems, rather than giving you the radius, they're going to give you the diameter. So the diameter goes all the way down. So the diameter is equal to, what do I have right here? I have a radius here and I have a radius here. So the diameter is equal to 2 times the radius, which means the radius is equal to the diameter divided by 2, or half of the diameter equals the radius. So that's going to be important. So right here, if the area of a circle is pi times radius squared, what do I do if they give me the diameter? I still do pi, but I do pi times, and I take that diameter and I cut it in half, and then I square it. So the area of a circle, you can either do pi times the radius squared, or if you're given the diameter, you could do pi times the diameter divided by 2, or half the diameter squared. All right, so these are the formulas we're going to be using. All right, so let's skip over a couple pages in the book and let's actually dive in and do some of these problems. All right, so if we look on the guided practice, by the way, I'm on page 274 if you wanted to turn there in your book. On page 274, numbers 1, 2, and 3, they've given us 3 circles and they've asked us to find the area. All right, so I'm going to write those formulas again right up here. The area of a circle is pi times the radius squared, or the area of a circle can be found by doing pi times the diameter divided by 2 squared because r and d divided by 2, those are the same. Half of the diameter equals the radius. So let's take a look at number 1. What did they give us on number 1? They gave us the diameter. It goes all the way across. So I'm going to write d equals 14. What did they give us on number 2? It only goes halfway. So on number 2, they gave us the radius. So the radius is equal to 12. What did they give us on number 3? On number 3, we're back going all the way across. So on number 3, they gave us the diameter, and the diameter is equal to 20. By the way, I'm not worrying, you'll notice, about the units right now. We'll go ahead and put the units on when we get our answer at the end. We're just going to focus on the numerical part here. All right, so if the diameter is 14, I have a question for you. What would it be if we went halfway across? What would the radius be? The radius would be half of that, right? Gosh, can't really see that. All right, so the radius would be what? The radius would be 7 meters. So right here, I'm going to write r equals 7. All right, so then we don't really need to know this, but you really need to get comfortable with going between radii and diameters. So even though we don't need to know the diameter for this problem, let's go ahead and figure out both of them. So for this one, if the radius is 12, what would the diameter be? What would it be all the way across? It would be what? Twice of that, 24, right? So the diameter is 24. And on this one, they gave us the diameter. So again, I'm asking you, well, what if we only went halfway across? What would that radius be? So if all the way across is 10, halfway across would be 10. Sorry, all the way across was 20. So halfway across is 10. So for each of these, we have the diameter and we have the radius. Now, if I asked you which one of these formulas looks easier, don't you agree that this one is easier, doing the radius, even though it's the same thing? So let's go ahead to each of these problems now that we know it, and I'm going to go ahead and I'm going to highlight the radius, right? Because that's the one I want to work with. So my recommendation to you is always get to the point where you know the radius. If they give you the radius right off the bat, you're good. If they give you the diameter, find the radius. Again, you're welcome to use this formula and actually take a half as you plug it in. But if you find the radius ahead of time, I just think it's easier to do the same thing every time. So for each of these problems, I'm going to have A equals pi r squared. Area is pi times radius squared. Area is pi times radius squared. Area is pi times radius squared. All right? Okay, so now what are we going to do? Every time you see pi, guess what? Pi equals pi. Pi is not a variable. Pi is a constant. It has a value. Pi is an irrational number that goes on forever. We often use 3.14, goes 3.14159 and keeps going on forever and ever and ever. If you have a calculator, there's a pi button on your calculator. So right here on this calculator, there's a pi button. And if you push the pi button, it will give you a whole bunch of numbers for pi. Your book usually says to use 3.14 for pi, so that's what I'm going to be sticking with. But you should know that pi isn't actually 3.14. It goes on forever and ever and ever and ever and ever. All right, so here we go. So this is going to be pi times the radius squared. But what did we say the radius was for this problem? It's 7. So this one is pi times 7 squared. That's going to give us our area. What about this one? This one is going to be pi times our radius. Remember, we're looking for the radius, not the diameter in this case. This one's going to be pi times 12 squared. What about this one? The radius right here. Here's the radius. The radius is 10. This one's going to be pi times 10 squared. All right. So pi times the radius squared. Once you've done that, now is a great time to go ahead and go to your calculator, and we're going to do this in our calculator. So I'm going to pull up my calculator. And I want to remind you, if you're using a scientific calculator is no order of operations. So you can put this in any order you want to, and it's going to do it correctly. But you should know that it's going to actually square. Exponents come before multiplication, right? You guys remember PEMDAS, P-E-M-D-A-S? All right. This squared right here, That's an exponent that's there and it comes before multiplication. But when you're using a scientific calculator, you could just put it in this order. So I'm going to do pi, but remember the book says to use 3.14, so I'm going to go 3.14 times, and then what am I going to do? I'm going to do 7 squared. Now, squared means times itself, so if you're not sure about doing squared on your calculator, you can do 7 times 7. I happen to actually have this x squared button, and if you have a scientific calculator, it probably does too. So 3.14 times 7 squared, and the answer that I get is 153.86. Now, 153.86 is what my calculator told me, excuse me. 153.86. But what do the instructions say? They say round to the nearest tenth. Well, the nearest tenth is 2 places. So I have 153.86. So I'm going to go 153. I'm sorry, the nearest tenth is 1 place. So I only want to have one number here. But I look after that number, and that number is 6. 6 is 5 or bigger, which means I need to round up. Remember, when the number to the right of your rounding place is 5 or bigger, you round up. So I get 153.9. And remember earlier when I said we would worry about the units? Well, now the units come into play. 153.9 what? Now, sometimes students put meters. But remember, what are we filling this circle with? We're filling this circle with squares. I don't want to know how many lengths of a meter there are. I want to know how many squares there are. And each one of those squares for this problem is a meter by a meter, and that means it's meters squared or square meters. So the answer we're looking for on this one is 153.9 square meters. What about this one? All right, I'm going to bring my calculator back up again. I'm going to clear out what I have in there, and I'm going to put in again pi times 12 squared, 3.14 times 12 to the second power. Again, there's my squared button right there, and I get an answer of 452.16. 452.16, but again, it says to round to the nearest tenth, so it's 452, and once again, that's 6 right there. There's my tenth space, right past the tenth place. That's 5 or bigger, so I'm going to round up to 452.2. This time my units are millimeters, but remember, when you find area, they are squared. That's not great here. It's mixing up with my radius. So I'm going to put it right below here. 452.2 millimeters squared, or square millimeters. That's the area of this circle. All right, and finally our last one. Here we go. Our last one, we have a radius of 10. So again, I'm going to clear this out, and I'm going to do pi times 10 squared. Now again, they told us to use 3.14 for pi times 10 to the second power. And when we do that, we get 314, which should not surprise us, because 10 to the second power is 100, and when you multiply by 100, it moves the decimal 2 places. So we got 3.14 times 100, 314. There's no rounding necessary. There were no decimal values. And our units this time, again, it's not yards, it is square yards. All right, so just to review, if you want to find the area of a circle, what are you doing? You're finding the amount of space it takes to actually fill in that circle, and you're filling in that circle with a bunch of little squares, and the squares have the units that go with it. So this one would be square meters, square millimeters, square yards. The formula that you use to find the area is pi times the radius squared. If they give you the diameter instead, like they did on number 1 and number 3, it's a great idea to divide that diameter in 2 and get the radius to start with and use that formula. Or if you want to, you can use this formula, pi times the diameter divided by 2 squared. But what I'm saying is, go ahead and do that part first, and then just use that formula. All right, we will do more problems later on solving problems using the formula for area and connecting it to circumference, but this video was just on how to find the area of a circle. I hope this helped you out. Have a great day.